So, example scenario 3. There is a box of crayons. It has one red, one yellow, one green, one blue, and one purple. If you take 3 crayons out one by one, then in how many different orders can you pull the crayons out? So this is slightly different. Like in the Quinn one, Quinn, Brian, and Christian, you had 3 people, 3 seats. In the math one, you had 4 letters, and you put them in arrangements of 4, permutations of 4. This time we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, 5 different colors, but you're only pulling out 3. So this is going to be slightly different. So let's say we have red. Well, then we can pull out yellow and then green. So this is going to be easier if I just write this down. Red, yellow, green, blue, purple. So red, yellow, green. We can also have red, yellow, blue. We can also have red, yellow, purple. Keep in mind, this is only with red, like first, and yellow second. So if we put red and then green, we could put yellow, red, green, blue, red, green, purple. Let's do red, blue, red, blue, yellow, red, blue, green, red, blue, purple. Now let's see if we can fit this last one here. So red, purple, red, purple, yellow, red, purple, green, red, purple, blue. Ooh, this is just red, right? But remember that you're going to be able to do the same thing for all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 permutations times 1, 2, 3, 4, 5. 5 of these, and which will give us 60 total permutations. You can write them all out if it helps you see them. That's fine. I feel like you don't want me to do that on video, right? So we're gonna say, yeah, that's fine. Now, if we're doing, okay. Well, let's see if this works the other way. So if we did the factorial method, we'd say we have 1, 2, 3, 4, 5. So 5 factorial. So 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Ooh, I don't know why it's slowing down. 120 times 1 is 120 permutations. I don't know why it's doing that. Okay, so we have 120. Now that's not the same. But you got to remember, this 5 factorial is trying to say that, like, on the first turn you have 5 to choose from. On the second turn you have 4 to choose from. On the third turn you have 3 to choose from. On the fourth turn you have 2 to choose from. On the fifth turn you have 1 to choose from. But remember, we're not pulling out combinations of 5. We're not going this one, this one, this one, this one, and this one. We're choosing this one, this one, this one, and stopping. We're only doing combinations of 3. So if we're only doing combinations of 3, you really need to stop. You had 5 to choose from, and then you had 4 to choose from, and then you had 3 to choose from. And then the rest don't matter. Like, those aren't there. The question is, how do you get rid of this and this? You can't just minus 2 times 1. Like, that's just not going to work. No, it's just not going to work. Because you can't undo multiplication with subtracting. Like, remember, so you can't just subtract it. But if we multiply by 2 times 1, Then to undo that, we would divide by 2 times 1. One way that we can write this is... So this is wrong, by the way. I'll just put wrong. One way that we can write this... I'm going to undo this equal. Okay, one way that you can write this is 5 factorial, because 5 times 4 times 3 times 2 times 1, over 2 factorial, 2 times 1. So over here, you should actually just write 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 times 1. But remember, we're only doing the first 3 terms, so you don't need the 2 times 1. And then you can just cancel out. Times 2 divided by 2 cancels out. It's times 1, right? Times 1 gets cancels out. So it's really a 5 times 4 times 3. 5 times 4 is 20. 20 times 3 is 60 total permutations. Which makes sense. I mean, you can kind of see it in here. All we did was leave out the last 2 turns because we didn't have like 5 turns, so to speak. All right, let's see if we can do this a little faster. So you have 6 friends. Yeah, 6 friends. You put their names on pieces of paper and randomly pull 2 out. The first name pulled will win a candy bar, and the second will win a bag of chips. How many permutations are possible? I want you to think about it. I'm just going to name them A, B, C, D, 1, 2, 3, 4, 5, 6. Okay. Now, we could go ahead and do everything like we did up here just to see everything. But... it's just like, I mean, if you understand this and you understand this, we can just like do it much shorter. So on the first turn, or like you pull out a name, how many possibilities do you have? You have 6, right? The second time you have 5. And then you don't have a third time, right? That's it. But let's pretend we did them all. 6 times 5 times 4 times 3 times 2 times 1. Well, you didn't need this times 4 times 3 times 2 times 1, right? So 4 times 3 times 2 times 1. I know it seems like we're like doing extra for being extra, you know what I mean? But I just want you to understand this before I just show you all the work that I want from y'all. So in all honesty, we want all 6 permutations, or 6 turns, we'll say. 6 turns of permutations. And then we really want to get rid of the last 4 because we want pairs of 2, right? So really, you can write this first, and then you can write it out like this so I understand, and then you can cancel out into the 1s that are there, and then you can go 6 times 5 is 30 permutations. All right. I might as well, once you get it, it's not too much work, so you might as well just write out the full answer. All right. So there are 22 different animals at the zoo, 1 of each. So you have enough time to see 3 of them. How many different orders of animals would you be able to see? So remember that if we took a turn for every single animal, we'd have like 20 turns, so to speak. But we only have 3 of them. Time to see 3. So you want to take away the last 17 turns. Now, I'm not going to write down everything, but I will write enough. So we do 20 times 19 times 18 times 17 times 16, and we keep going on, right? And then we're going to do 17 times 16 times 15. Oh, I need that 15 because I didn't write it up there. Now, remember, this is what we're really doing is we're taking all the turns to get all the permutations possible, and then we're taking away the last part of it. So really, this goes. Oh, these go away. These go away. That goes away. That goes away. That goes away. That goes away. So it's really 20 factorial 17 over 17 factorial will give me. I'm not gonna do that. I mean, I guess I could, but y'all can do that, and then y'all find the answer, and then that many permutations. All right. Thank you.